Welcome to stoichiometry. Stoichiometry is a section of chemistry that involves using relationships between reactants and/or products in a chemical reaction to determine desired quantitative data. In order to use stoichiometry to run calculations about chemical reactions, it is important to first understand the relationships that exist between products and reactants and why they exist, which require understanding how to balance reactions. Points to remember. The reactants are displayed on the left side of the equation, and the products are shown on the right side of equation. They are separated by either a single or double arrow that signifies the direction of the reaction. To balance the equation, there should be same number of atoms on left and right side of the equation. The following equation demonstrates the typical format of a chemical equation. 2Na2HCl makes sodium chloride H2. In this reaction, sodium, Na, hydrogen, H, and chloride, Cl, are the elements present in both reactants, so based on the law of conservation of mass, they are also present on the product side of the equations. Stoichiometric coefficient. It is the number written in front of atoms, ion and molecules in a chemical reaction to balance the number of each element on both the reactant and product sides of the equation. This stoichiometric coefficients are useful since they establish the mole ratio between reactants and products. 2Na2HCl makes 2 sodium chloride H2. We can determine that 2 moles of HCl will react with 2 moles of Na to form 2 moles of sodium chloride and 1 mole of H2. If we know how many moles of Na we start out with, we can use the ratio of 2 moles of sodium chloride to 2 moles of Na to determine how many moles of sodium chloride were produced, or we can use the ration of 1 mole of H2 to 2 moles of Na to convert to sodium chloride. Example. Balance the reaction. Lead, IV, hydroxide and sulfuric acid react to form lead sulfate plus water. Solution. You will start by counting the number of atoms for each element. Lead number of reactant equals 1. Number of product equals 1. Oxygen number of reactant equals 8. Number of product equals 9. Hydrogen number of reactant equals 6. Number of product equals 2. Sulfur number of reactant equals 1. Number of product equals 2. The reaction has 16 reactant atoms and only 14 product atoms and does not obey the conservation of mass principle, which states that matter can neither be created nor destroyed. Stoichiometric coefficients must be added to make the equation balanced. In this example, there are only 1 sulfur atom present on the reactant side, so a coefficient of 2 should be added in front of H2SO4 to have an equal number of sulfur on both sides of the equation. Since there are 12 oxygen on the reactant side and only 9 on the product side, a 4 coefficient should be added in front of H2O where there is a deficiency of oxygen. Count the number of elements now present on either side of the equation. Since the numbers are the same, the equation is now balanced. Lead hydroxide and sulfuric acid makes lead sulfate and water.